All right, welcome to topic 8.2, human impacts on ecosystems. Now, we're going to look at how humans affect the world around us, mainly in terms of how we affect biodiversity, how we manipulate the world around us, and how what we can do can lead to extinction and, in general, a turnover of living things. So here is something we've been doing for thousands and thousands of years, and that's using fire to impact our environment, to clear out brush, to grow crops, or to make a place where animals might gather that we can then hunt. So fire is one of these things that humans have used for thousands and thousands of years to kind of shape the world around us. Sometimes these ways can be in sync with our environment, but as we know now, just in the overall power of us to impact the environment, it tends to be less positive. So organisms have a range of tolerance for different pollutants. So I forgot to block these out, but go ahead and just write this on your paper. You'll see in this certain range, see a temperature range, see, because heat pollution can be a problem in a lot of aquatic ecosystems. In this favorable range, you see a large number of organisms, but if you go too high or too low, you enter these zones where you get fewer and fewer, and then finally no organisms will exist. It's always about homeostasis, about balance. So we got to be careful about how we affect the temperature of the water in terms of especially power plants, is where this comes into biggest effect. Coral reefs, something that's really been on our mind because we see a lot of bleaching happening around the world from ocean acidification and climate change and nutrient loading, to putting too many nutrients in the ocean. So increasing ocean temperature, sediment that just blocks out the light, reduces photosynthesis, runoff, putting a lot of nutrients and pesticides into the water, and destructive fishing practices. And you might think, what is a destructive fishing practice? This is fishermen using dynamite. They basically blast the coral, and then the fish float up, and then they get them. So this obviously destroys a lot more living things than just the fish they're looking at. So these kind of practices, and just huge nets going everywhere and then blocking things. Oil spills is a big problem, especially coating the feathers of birds and the fur. And what this does is reduces the ability to keep the animal warm. And then it gets cold and dies. So unless people come in and try to wash the oil off, they'll probably die. And also, you think, well, then since oil floats, then everything underneath should be okay over time, but no, eventually it coagulates and then sinks, and those hydrocarbons can then go down and create a toxic environment for the food chains that exist kind of on the bottom. So it's just a big problem. The oil eventually will biodegrade, but it can, in the meantime, cause a lot of trouble in those food chains, increasing toxicity. So the best case scenario, if there is an oil spill, is to gather up as much of that oil as possible, put booms out, vacuum it up. That's what's happened they try to do currently to deal with oil spills. And when it happens, this right here, Santa Barbara in 1969. Huge oil spill. And it came from this platform here. It's a blowout, just leaking oil everywhere. And it can really affect the fishing and tourism industries. Santa Barbara is kind of thought of as, huge tourist town, and it's a beautiful spot. And when you have oil everywhere, it definitely decreases people wanting to go visit. You can get these oceanic dead zones, like you see. This is Louisiana. This is Texas, and this is Mississippi. This is Alabama. And we see this is the Mississippi coming through here, and then this is the outfall into the Gulf of Mexico. And this is these are the dead zones. The red equals dead. And we can see this is from the nutrients and sediments coming down from all the farming along the Mississippi. And what it does, it just really reduces the amount of oxygen in the ocean. Without oxygen, marine life can't exist. And you have a giant problem, and that affects, of course, the whole food chain. So looking specifically what happens with nutrient pollution, you have excess nutrients. We see here phosphate and nitrogen primarily. And then what that creates is a rapidly growing algae population. Blocks out the sun. That prevents photosynthesis from happening. And then oxygen levels fall. O2 levels go down. And when that happens, also bacteria feed on the algae, and those bacteria use up oxygen as they're undergoing respiration. Remember, respiration, C6H12O6 plus oxygen gives us carbon dioxide and water. So they use up a lot of oxygen in that process. And animals are living there. They need oxygen. The fishes, they can't get oxygen. They die. And then everything dies. And that depletes more oxygen. Okay, so it's a positive feedback loop. It just creates extremely low oxygen conditions. And this is a nice diagram. It shows something called an oxygen sag curve. And this shows dissolved oxygen levels. Where am I? There I am. Versus the distance from the source of the pollution, usually excess nutrients and biological refuse. So here we have a pipe. This might be a sewage pipe, looks like. And see, normally you have, these are your dissolved oxygen levels. Right up here, and down here something called BOD, and that stands for biological oxygen demand. And what that does, let me write that over here, BOD. What that is a measure of organic material. In the water. So we can see at the beginning, this is, right here, normal, everything's good. We got a lot of oxygen, very low organic material. Then, boom, we go downstream, we hit this outfall, our oxygen levels go down. Okay, because look, that biological oxygen, we have a lot of organic materials. And as the bacteria start to eat things up, they're using that oxygen, and that's reducing the oxygen level. This is from bacteria cause this. And also because they're eating it, they make the levels go down. So you end up having some fishes, some organisms that can tolerate this, but a lot of them can't. And then we go finally the septic zone. They keep eating and eating and eating, and the oxygen level just become really low. So you don't have hardly anything, hardly any fish, sludge, worms, bacteria, very low oxygen. We'll say very low. Yeah, see how the oxygen is down here. Eventually, it will recover because all that biological material will be used up. See that level, it keeps decreasing. So it's going down, 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 down. And once it gets low, like where it was before, so this is before, this is after all the bacteria is eating it, the oxygen levels start to go back up. Okay, as you get normal aquatic plants photosynthesizing, and then you basically see a recovery. So this tends to happen wherever you have a river like the Mississippi or the Missouri or the Ohio. Every town it hits, there's just more waste that goes in that water, and you see this effect of the oxygen levels dipping and then rising again later. All right, we'll go ahead and end here, and then do part 2 in the next video.